learners, welcome for the 5th week course on cybersecurity. In this week, we are going to discuss about security models, ISO 27001 model, different security mechanisms. This is the first phase we are in. No doubt, computer security is a challenging task because the requirements vary with respect to applications, systems, organizations, and sometimes even people. It gives different perspectives to different people. There are several aspects of a system that has to be secured, and security solution implementations happen at various levels, of course with varying degrees. Depending on the need and requirements, many security models are discussed in the literature. Let us deliberate on some significant security models, the ISO 27001 model, and important security mechanisms in this phase. What is a security model? A security model may be a structure that outlines the essential needs necessary to support and implement the security policy. First of all, the security policy dictates the guidelines the user and the organization must follow with reference to the assets, especially with reference to the computer resources, network resources, and data. The security model might prescribe an access control matrix to fulfill and monitor the security policy laid down. There are certain computer security models followed widely. Some of them quoted by Wikipedia are Access Control List, State Machine Model, Bell-LaPadula Model, Biba Model, Brewer and Nash Model, Capability-Based Security, Clark-Wilson Model, Context-Based Access Control, Graham-Denning Model, Harrison, Russo and Willman Model, High Watermark, Lattice-Based Access Control, Mandatory Access Control, Multi-Level Security, Non-Interference, Object Capability Model, Protection Ring, Role-Based Access Control, Take Grant Protection Model, Discretionary Access Control. We will discuss a few of the general approaches in this phase. The first one is Access Control List. This refers to the list of permissions attached to an object. It mentions who are all the users or which are all the processes that are granted access to the objects. Generally, it is organized in the form of a matrix. We'll discuss in detail in the coming section about it. The second one is State Machine Model. It is a mathematical model that teams all attainable system occurrences referred to as states. Every attainable state of the system is evaluated, showing all attainable interactions between the subjects and the objects. If each state is tried to be secure, the system is proven to be secure. State Machine Model is used to model a software package. Generally, this may be used to model and test how an object moves from an inactive state to an active state, readily accepting the inputs and providing the outputs in the object-oriented programming scenario. The third one is known as Bell-LaPadula Model. This is a state machine model used for enforcing access control in government and military applications. It is applied to build multi-level security in the Department of Defense, US. It uses security labels on objects for authorization and also for subjects. The Bell-LaPadula model focuses on data confidentiality and controlled access to classified information only. The next one is Biba model. It is a formal state transition system of computer security policy that describes a set of access control rules designed to ensure data integrity. Data and subjects are grouped into ordered levels of integrity. While several government applications are primarily involved with confidentiality, most business applications desire to confirm that the integrity of the data is protected at the very best level. Biba is the suitable model once integrity protection is important. Not only it prevents unauthorized access or modifications, it also maintains internal and external consistency, which are also equally important for an organization. Biba model ensures that. The next fifth model is information flow model. This model describes how information may flow in a secure system. Both Bell-LaPadula and Biba use the data flow model. Bell-LaPadula states no read up and no write down. For example, information flow describes how unclassified data may be read up to secret and then written down to top secret. Biba reverses the information flow path to protect integrity. The next one is the Chinese wall model. The Chinese wall model is intended to avoid conflicts of interest by prohibiting one person, like an advisor, from accessing multiple conflicts of interest categories. It is additionally referred to as Brewer-Nash, named after the creators Dr. David Brewer and Dr. Michael Nash, and it was initially designed to address the risks inherent with employing consultants working within banking and financial institutions. Conflicts of interest pertain to accessing companies' sensitive data from different firms that are in direct competition with each other. If a consultant had access to competitors' banks' profit margins, then the information may be used for personal gain also. The next model is non-interference model. The non-interference model ensures that knowledge at totally different security domains stays separate from each other. In simpler terms, a computer is modeled as a machine with inputs and outputs. Inputs and outputs are classified as either low or high. A computer has a non-interference property if and only if any sequence of low inputs will produce the same low outputs regardless of what the high-level inputs are. By implementing this model, the organization can be assured that covered channel communication does not occur. Fundamentally, a covered channel is a type of attack that creates a capability to transfer information objects between processes that are not supposed to be allowed according to the security policy entrusted. A covered channel is a policy violating communication that is hidden from the owner or the user of a system. I can explain this with the help of an example. There are unused fields within the TCP/IP headers, which can be used for covered channels. These fields may carry covered traffic along with the encrypted payload data within the packet. Many kinds of malwares use these type of fields as covered channels for human action back to malware command and control networks. The next type is take-grant. Take-grant protection model contains the rules that govern the interactions between the subjects and objects and permissions subjects can grant to other subjects. Rules include here are like take, grant, create and remove. The rules are depicted as a protection graph that governs the allowable actions. Each subject and object would be represented on the graph. The following figure depicts this take-grant relationship between the users Alice, Bob and Carol. Subject Alice, who is placed in the middle of the graph, can create a takeaway C and R, any privileges for the key documents. Alice can also grant G, the user Carol, for any of those same privileges. Whereas user Bob will take T, any of user Alice's privileges. Take-grant models are often very advanced as the relationships between the subjects and objects are usually much more complex than the one shown here in this picture. The next model is Harrison-Russo-Ullman model. Shortly, it is known as HRU. The HRU security model is an operating level computer security model that deals with the integrity of access rights in the system. The HRU model has defined the access rights to an access matrix which maps the subjects and objects. The HRU model defines a protection system consisting of a set of generic rights R and a set of commands C. Fundamentally, it is defined as a tuple SOP. S refers to the current subject, O the current object, and P the access matrix. This model has 6 primitive operations. They are create subject, create object, destroy subject, destroy object, enter right into the access matrix and delete right from the access matrix. So far we have discussed different security models available that are very popular and plays a major role in the system.